Hi, geometry students. We are going to be continuing on looking at surface area. Now, we previously looked at just general solids and seeing them in 3D shape. Now, today we're going to specifically focus on two of those that we started to look at out of the four. So today we're going to start looking at prisms, and then tomorrow in class we're going to finish up with cylinders. So go ahead and pull out your surface area and volume packets. We are going to go ahead and open up to page 3. So let's go ahead and start filling in what we know already about a prism. So remember before, we know a prism has two congruent and parallel bases. So go ahead and fill that on in. Now keep in mind from our picture below, we can see there's an example of this, right? It's our triangular prism. So keeping in mind, I highlighted the bases kind of in this lighter blue. We know that they're congruent and they're parallel to each other. There's two of them. Now keep in mind the lateral faces, those are the rectangles. So these are kind of like the sides of them, this whole one right here and that side, because remember, we're looking at 3D shapes. So let's fill that in right here, that our lateral faces here are rectangular. Now, keep in mind, right, we know that we're looking at, in blue, our two bases, so let's go ahead and label both of them on top and on bottom here. And something to kind of point out is that there is a 90-degree angle created here, so this is a specific type of prism, not just a triangular, but we can actually say this is a right prism. Now, one more thing I did want to point out here. Keep in mind that, yes, this is an edge between two of our rectangles, and it also has the vertices connected to our triangles, those bases. But keep in mind, this is our height. The height is our distance between these bases. So we're going to go ahead and add that on here, that the height is the distance between bases. So we're using this word lateral, right? We're using this to describe some of our faces. We also could use a base for the certain faces. Now, remember, we're going to talk about the difference between lateral area and surface area. This is a huge concept. So if you need to put a star by this, this is something that's going to carry on throughout our whole entire notes. When we're looking at our lateral area, that is the area of all the lateral faces. So just each of these sides. It does not include our bases. So that's something important that we want to put down here. That our lateral area is the area of all the sides, and it is excluding the bases. So in this picture, it would be all three of these rectangles. Whereas now when we're looking at surface area, we're looking at what covers the entire surface, right? The whole outside. So it's the area of all of our sides together. All of those two-dimensional areas. It will include the sides and the base. So for surface area, we can fill in that as the area of all sides. So now we're going to take this idea of lateral and surface area, and we're going to start to apply it to different figures. So keep in mind lateral and surface area, that idea that we just came up with, right? Lateral is the area of all sides excluding the base, and our surface area is the area of all sides. We're going to use this going forward. So specifically today, like I said, we are focusing on prisms, and looking at class tomorrow, we're going to focus on cylinders. So we're going to look at the area formulas for the lateral aspects and the surface area aspects. So keep in mind, something else we want to add here is, remember, surface area is our total. So I like to sometimes add that on in there. And just as a reminder, I know we kind of wrote it up above, but we're going to write it down again. So keep in mind, the lateral area is the area of the lateral surfaces. So all of the sides. And our surface area is the area of all faces. So for lateral area, right, it's essentially lateral surface area versus total surface area. So I like to abbreviate them using letters. So for lateral surface area, I will always be abbreviating it with LSA. And for total surface area, I'm going to abbreviate it as TSA. So nothing to do with flying just yet, but that's how I'm going to abbreviate both of these. So if we're looking at the area of our lateral surfaces, keep in mind, essentially what we're doing with a prism is we're going to introduce the idea of the perimeter of our base and the height of our prism. So looking at this, we're going to use P to represent the perimeter of our base, and H will represent the height of our prism. So to find just the lateral surface area, right, all of those sides, what we're actually going to do is take our perimeter of our base and multiply it by the height of our prism. So going back up to our picture up here, we want the perimeter of our base, so all three of these sides added together, and then our height that we're working with. So that will give us our lateral area. Now going to our total surface area, again, we're essentially taking what we got as our lateral surface area, right? Our perimeter times height. So again, we can abbreviate it LSA. And we're going to add on what we get for our two bases. So instead of just saying that in words, I'm going to use the letter B to represent the area of these bases, right? Because we're looking at area. So we're going to add to the lateral surface area, we're going to add 2B, which is 2 areas of the bases. All right, so look at that. We kind of have our formulas all down here for our prism, and now we're going to practice applying these in the example below. So kind of as a strategy, like I said, I'm going to be using a little bit of color to help me identify each of our parts. So let's go ahead and look at our figure below and read the directions for what it's asking us to do. So it says, what is the name of this prism? So keep in mind, we name prisms by the shape of their bases. So what do you think it is? That's right, it is a triangular prism. So now maybe let's label each of our bases. So go ahead and label each of the bases. And keep in mind, for this picture, you know, it's different from the one above, right? Because it's at a different height. Our height now is actually 20 down here. So we're gonna go ahead and label this 20 as our height because it's the distance between our bases. So we're gonna find the lateral area and then we're gonna find the surface area. So keep in mind, we do need this information up here to help us. So let's start off with our lateral area. We're gonna go ahead and try to find the perimeter of our base. So remember, it gives us these sides. Keep in mind, it also gives us 15 over here, so we can add 12, 14, and 15 together to get the perimeter of our base. So that's gonna be 41 for our base. Now, remember, that's the perimeter, right? The distance around it. Now, eventually, you know, we already know what the height is here. So let's find out what B is, the area of the base. So throw back to what we learned a couple of weeks ago, right? This is a triangle. To find the area, it's 1/2 base times height. So 1/2, 14 times 13. So thankfully, they gave us what that perpendicular height was. So if we do 1/2 base times height, right, 1/2, 14 times 13, we actually end up getting 91. So the purpose of me looking for these ahead of time is just so I can easily plug them into the formula. Again, you could come up with the formula first and then solve for them. It doesn't matter either way, but I'm going to go ahead and find the lateral area. So I'm going to go ahead and write down my formula of lateral surface area equals my perimeter times my height. And then I'm going to plug in my two pieces of information that I have, my 41 and my 20. So I'm going to have 41 times 20. 820. So put that in our calculator, we get 820, and keep in mind, this is area, right? Lateral surface area. It's basically the area without the bases, so we want to label that as units squared, so I have 820 units squared. So now, let's go ahead and try to find the total surface area. So again, let's write down our formula of our total surface area. That's our lateral surface area plus 2 times the area of the bases. So again, we found the area of the bases here. So we're essentially taking 820 and adding 2 times b, which is 2 times 91. So let's go ahead and write that on down. All right, so using our calculator, putting this in, we now get a total surface area of 1,002 units squared. We're going to go ahead and head to the next page to practice a couple more problems where I'll do one more example with you and I will have you do 2 examples and check your answer to what you get. All right, let's go ahead. We're on the next page. I'm actually going to have you go ahead and try number 2 on your own. So again, it is a triangular prism, so we know what the name of it is already. I want you to find its lateral and surface area. So if you need to look back at example 1 to kind of help you out, you can, but go ahead and pause the video right here, try the problem, and then we'll come back and talk about it. All right, let's go ahead and go over this problem. So we know it's a triangular prism, and to kind of help us out, I'm going to label the pieces I know. So we know that that side of our triangle is 17. We know that the 18 represents the height. And keep in mind, we know our lateral surface area formula. It's perimeter times height. And we also know our total surface area, right? It's what we get for our lateral surface area plus 2 times b. So maybe let's go ahead and find out what our perimeter is and our area of our base. So keep in mind our perimeter is all 3 of these sides added together. So our perimeter will actually be 40. And then keep in mind our area of our base is going to be 1/2 base times height. So it's 1/2 base of 15 times 8, our height. So when we do that, we get 60. And now we can plug everything into the formulas. So for our lateral surface area, right, it's 40 times 18. So that will get 720 centimeters squared. And then for our total surface area, we take that 720 meters squared and we add it to 2 times our base, which is 60. So that gives us 840 centimeters squared. So, problem wasn't too bad, right? Because you had a good example to look at before. Awesome, awesome. All right. So we are going to come back and do number 3 together. But I want you to try number 4 now on your own. I'm not going to go through and explain it as much as the other one I just did up here. I'm going to show you my answer at the end, but it's really not too different from our triangular prism. I actually think it's a little bit easier because we're essentially looking at rectangles on the side. So go ahead, pause the video, do the example number 4 prism. All right, let's go ahead and go over this. So for our lateral surface area, you should have gotten 420 centimeters squared. And for our total surface area, you should have gotten 518 centimeters squared. If you need to check my work and your results a little bit more, pause the video here. We are going to go on to our last example for class today. Ooh, all right. It's actually a pretty tough example. So let's look at example number 3. So here we can see we're looking at this example below, and I kind of already started to draw some ideas off of it. Don't mind me for a second, but I wanted to show you that we have a little bit of shading that we're looking at. Here we can see these are our bases, and they're actually hexagons. So we know that this actually will be a hexagonal prism. Now, the tough part with this, right, is we know our formulas, right? We know the lateral surface area is our perimeter of our base times our height. And we know our total surface area is the lateral surface area plus 2 times the area of our base. But this is tricky because now we're looking at a hexagon. It's not as easy as a triangle or, you know, our rectangle or quadrilateral. So we kind of have to think about how we're able to approach this. So it gives us that each of these side lengths is 4 centimeters. Well, that's kind of easy to figure out the perimeter, right? It's just going to be 4 times 6. So we know our perimeter is going to be 24. Now, keep in mind, we are already given the height. That's great. But now we have to find the base, right? The area of this. Ugh, it's kind of tricky to figure that out. We don't really have a formula that we know of for area of a hexagon. So I kind of gave you a little bit of clue here. So I want you to go ahead and draw this center point of our hexagon. And I want you to draw a right triangle. So think about this, and we're really expanding kind of off of our knowledge. Think about how we could, if I didn't have this divider, I could create triangles here that go around our hexagon. And there would be technically 6 big triangles. And when we divide them in half, then there would be 12. So we can actually think about this in a different way. We can think about how altogether we have 360 degrees. And when we divide it by 12, we actually get 30 degrees. So this top angle is a 30 degrees. So that means this bottom angle is also 60 degrees as well, double of our 30. So I'm actually going to kind of redraw the picture of that over here. And you're probably thinking, wait a minute, this is special right triangles, right? So we're looking over here that we have our 30 degrees on top, our 60 degrees on the bottom, right? So that means we have our short leg times root 3, and then we have our hypotenuse as the short leg times 2. Keep in mind that this whole length is 4. This is bisected, it's cut in half, so we know our short leg is 2. So think about this. We can find, right, the area of our triangle, right? We can look at that and multiply our height times the base, right, times half, but then we could multiply that times all 12 triangles. Well, it's a little bit tricky on how to do this, right? So think of maybe what we know about the areas of hexagons, right? That formula is going to be 1/2 times this radius times the perimeter. So we're really throwing it back to what you've seen before, right? We could look at this in 2 ways. So our base for a hexagon is 1/2 times whatever the radius is, which we have 2√3. And then we know our perimeter. So it builds off of what we already have. So we're going to multiply it times our perimeter. Now, just for an easier sake of this problem, I'm going to keep it in radical form so that way I'm not rounding mid-problem. So I'm going to keep this as 24 radical 3, and I'm going to plug in everything appropriately right on up here. So let's go ahead. Our perimeter is 24. Our height is 17 from our picture. When we multiply those two together, I get 408. So we know that's our lateral surface area, 408, and it gives us centimeters squared for our units. Now take that lateral surface and we're going to add it to 2 times the base area, which is our hexagonal area of 24√3. Now, again, I could put this in decimal form. I'm honestly just going to keep it in simplest radical form just so it's a little bit more exact. Again, in the future, they'll probably tell you more directions on this. For me, I just want to focus on simplest radical form for the sake of it. So we're going to have 408. And we're going to add that to 48 square root of 3, and that is going to be centimeters squared. All right, so we are done with our lesson for today. Looking good. So tomorrow in class, we're going to start to go over cylinders more. So figuring out, what the lateral surface area and the total surface area of that is. So I will see you tomorrow.